Right, so integration here by substitution, do you know 6, right? What you'll notice here, because we've got trig functions, right? You've got to make sure your calculator's in radian mode, okay? Big clue here, of course, because the limit there is pi over 6, yeah? Pi over 6 we know is radian measure, all right? But whenever we're integrating or differentiation, it's always radians, right? It's got to be radians. So the substitution u is, what is it, 2 sine x plus 3. So don't forget then, the first thing I do with the substitution is differentiate it. So u on the left-hand side, yeah? U on the left-hand side, x on the right-hand side. So it would be du with respect to x. And when you differentiate sine x, it just becomes cos x, doesn't it? So, of course, there's a 2 in front of it. So 2 sine x becomes 2 cos x. Okay? Plus 3, well, that 3 just goes then, doesn't it? And remember, I want to replace dx, okay? So if I take that dx up, I'll have u equals 2 cos x times dx, because you take it up in times. And then remember, I want to work out what dx is. So to get dx on its own, I got to take that 2 cos x down, so that will become 2 cos x equals dx, yeah? We just take that down and divide by the gu. So before we substitute, before we actually do the integral, remember then we need to do the limits, okay? So these limits now, don't forget now, and in terms of that letter, that variable there, yeah? So that's an x value, and that's an x value. So to get the u value, I just substitute it in. So when x is 0, u will equal 2 sine 0 plus 3, okay? So you can check that on your calculator, but remember, it's got to be in radian mode, okay? So, and you get 3 out. And when you put x is pi over 6 in, you get 2 sine pi over 6 plus 3, okay? And of course, you've got to have something sensible out from this, and we get 4, okay? So those are my new limits. So when it comes to the integral then, okay, I call it I, yeah? I'm not going to rewrite all that out again, so I'll just put I for integral. My new limits now 0 maps to 3, yeah? Always make sure the ones you change, they correspond, so that 3 does correspond to the 0. The 4 corresponds to pi over 6. So then when we substitute it in, let's look at the top here, cos x. Now cos x, right, isn't part of the substitution, isn't it? It's just not there, okay? Cos x is not in there. All right, we've got sine x, so we can't actually substitute that. So we just leave that as cos x for a minute. Okay. On the bottom then, 2 sine x plus 3 all squared. But of course, 2 sine x plus 3 is u, isn't it? So we just get u squared. Don't panic that we've got that cos x there. Don't panic about it just yet. Okay, because you see what happens now. Dx, of course, we'll replace that, and that just becomes du over 2 cos x. Okay. And notice what happens nicely then. The cos x's will cancel. You've got cos x on the top, cos x on the bottom. Cos x divided by cos x is 1. Fantastic. Christmas Day, right? They cancel out, and there's no x involved here now. So what you end up having is, on the top, well, there's nothing there as such. Well, you're just going to write 1, isn't it? On the bottom, you've got 2 here and u squared. So it'll be 2u squared du. Now what I would do to integrate this, I take out the half to start with, because you've got a half here. Take it out of the integral, because that's not needed. It's easier to take it outside. Now the u squared's on the bottom. To integrate that, you need to take it up. So u to the minus 2. And then when we integrate it, square bracket, u to the minus 2. Well, if we add 1 to it, then when you integrate it becomes minus 1. Add 1 to it, but divide by that new power. And then between 4 and 3. So remember, it's simple integration there. Just add 1 to the power and then divide by that new power. So this becomes, in the bracket then, you get minus, isn't it? There's a minus 1 on the bottom. And what we could do is we could take that u back down, couldn't we? Because this is u to the power minus 1. Take it down, so it becomes u to the power 1. There's a minus there. And put in then the limits. So you get minus 1/4. And then in here, and then take away there, don't forget the half, and put in minus 1/3 in there. Okay, so if I work that out on my calculator, I get 1/24. which is perfect. Okay, so not too bad once you've done the substitution.